Imagine a symphony written in the stars, where the silence of the cosmos plays as profoundly as the notes themselves. Picture a canvas vast and dark, punctuated by punctual bursts of luminous entities, each a whisper of an ancient secret. Amidst this celestial quietude, there exists a planet, K2-18b, a mysterious orb cloaked in shades of possibility, swirling with atmospheric whispers that speak of life's potential ballet. This planet, wrapped in a veil of hydrogen, hosts clouds that murmur in chemical tongues. Dimethyl sulfide, DMS, and dimethyl disulfide, DMDS, dance through its skies, molecules that on Earth are penned by life itself. As the James Webb Telescope peers through cosmic time, its gaze unearths these subtle signatures, etching a story of existence that might mirror our own. We stand at the shoreline of the universe, gazing out into an ocean of galaxies, each wave cresting with its own enigmatic tales. K2-18b beckons us with its siren call, a beacon in the cosmic dark. Its air, rich with the fingerprints of chemistry that could mean life, whispers a tantalizing tale. But what lies behind this cosmic veil? What stories await us in the silent symphony of the stars? In the boundless theater of the cosmos, where stars are born and galaxies whirl in silent dances, the James Webb Space Telescope has cast its gaze upon a scene that might just rewrite the narrative of life beyond our blue Earth. Floating in a quiet corner of the universe, the exoplanet K2-18b emerges as a character shrouded in mystery and draped in a cloak of potential light. Imagine a world where the skies are brushed with strokes of hydrogen-rich clouds, and the air carries the faint scent of chemicals familiar yet alien: dimethyl sulfide, DMS, and dimethyl disulfide, DMDS, molecules intertwined with life on Earth. Here dance through the atmosphere of K2-18b. On Earth, these compounds are byproducts of biological activity, whispers of life itself, floating from the ocean waves into the embracing sky. Their detection on K2-18b by the James Webb's sensitive instruments suggests not just chemical reactions, but whispers of a potentially thriving ecosystem hidden beneath the cloud cover of this distant world. Consider the scale of this revelation. A planet, over 110 light-years away, might harbor the same chemical signatures associated with life as we know it. The James Webb Telescope, a marvel of human ingenuity floating in the cold, expansive silence of space, serves as our bridge to these distant biological horizons. Its mission to peer into the atmospheres of far-off worlds uses the most advanced technology ever deployed beyond Earth, capturing light that has traveled unimaginable distances to tell us a story of possibility and wonder. The emotional weight of this discovery cannot be overstated. Each molecule of DMS and DMDS detected is like a note in a cosmic symphony, hinting at the universal nature of life. It is a reminder of our shared beginnings, stardust to stardust, bound by the same fundamental rules that govern the most distant reaches of space and time. In the grand tapestry of the universe, K2-18b is but one thread, yet its story is a compelling chapter in our ongoing quest to understand our place among the stars. What does it mean to discover such Earth-like processes on a world so alien? How do we reconcile our feelings of insignificance with the awe of connection to something as vast as the universe itself? As we stand at this crossroads of knowledge and mystery, the James Webb Space Telescope continues to probe the depths of space, seeking more clues hidden in the light of distant stars. What truths might be hidden within this infinite architecture? Imagine a canvas painted with the vastness of space, where the James Webb Telescope gently unveils the secrets of the universe, one celestial body at a time. Among these, K2-18b emerges, a distant world where whispers of life echo through its atmosphere, rich in dimethyl sulfide and dimethyl disulfide. These molecules, akin to faint brush strokes of life on Earth, suggest a dance of biological processes under the shroud of alien clouds. If this glimpse into the cosmos stirs something within you, if it sparks a curiosity about our place in this endless tapestry, I invite you to share your thoughts and feelings. Let your voice echo in the comments. Join this celestial journey of discovery and connection. Let's weave our stories into the fabric of the universe. Now, let's return to where it all began, under the same stars that witnessed the birth of everything we know. In the beginning, there was nothing but a vast, silent expanse, an infinite void where time itself lay dormant. This primordial silence, thick and unbroken, was the canvas upon which the cosmos would sketch its first strokes of existence. Imagine then a universe in its embryonic stage, stirring in the darkness as if it were the belly of a celestial beast. Within this quiet womb of potential, chaos reigned supreme, a swirling melange of gas and dust, dancing furiously as though preparing for the grand spectacle of creation. It was a cosmic ballet, choreographed by the forces of gravity and chance, where particles collided and embraced under the orchestration of unseen laws. From this chaotic embrace, stars were born, tremendous furnaces of light and heat. These newborn stars were like the first cries of life echoing through the void, shattering the silence with their radiant existence. They burned with a fierce, primal fire, converting hydrogen into helium, forging the fundamental building blocks of everything that would ever be. In their fiery hearts, heavier elements were crafted: carbon, oxygen, iron, the very elements that would one day compose the mountains, oceans, and even life itself on worlds untold. As these stars lived and died, their final breaths were events of unspeakable beauty and violence. Supernovae exploded like great celestial flowers, casting their seeded petals of enriched stardust out into the galaxy. This dust, enriched with the ashes of stellar deaths, became the material from which new stars, planets, and possibly life would eventually form. Consider the life cycle of a star not just as an astronomical event, but as a narrative of existence itself, a story of birth, life, death, and rebirth. From the remnants of these cosmic firestorms, solar systems were sculpted, and planets coalesced from the remnants of ancient extinguished stars. Each world a silent testament to the cycles of destruction and creation that define our universe. And so, from the celestial dust, nurtured by the remnants of 1,000 suns, K2-18b emerged. Circling its host star, this exoplanet carries within its clouds the whispers of those ancient stellar events. Its atmosphere, rich with hydrogen and traces of dimethyl sulfide and dimethyl disulfide, suggests not just the mechanical processes of chemistry, but the potential echoes of biological processes. Could it be that this distant world mirrors our own in its capacity to harbor life? On Earth, these chemicals are the fingerprints of life, of algae blooming in the oceans, and of the earthy scent that follows a spring rain. Their presence on K2-18b tantalizingly suggests that, perhaps, we are not alone in the cosmos, that life is not a rarity, but a common flourish amidst the vast starry garden of the universe. With the James Webb Telescope, we peer across the expanse of space and time, reaching back to the echoes of creation to understand more deeply not only the universe, but also ourselves. Through its lens, we glimpse the potential of other worlds, other stories, and other lives, bound together by the same stardust that once formed the planets and stars. As we stand on the brink of these cosmic revelations, gazing into the depths of space, with our feet planted on the soil of our own world, we must ask ourselves, what remains buried in that ancient silence? As we gaze into the cosmos through the eyes of the James Webb Telescope, we peer into a diary written not in words, but in the language of light and shadows. Each photon that reaches us from the distant exoplanet K2-18b carries tales of cosmic events, a narrative of creation and existence spread over billions of years. In this grand book of the universe, each chapter tells of starlight captured, of atoms formed in the fiery hearts of long-vanished stars. The most promising pages of this cosmic diary are those that whisper hints of life beyond our Earth. K2-18b, a Hycean world enveloped in a thick, hydrogen-rich atmosphere, presents us with such whispers. Detected by the precision of the James Webb, dimethyl sulfide, DMS, and dimethyl disulfide, DMDS, float within this exoplanet's air. On Earth, these molecules are the fingerprints of life, commonly produced by marine organisms. Their presence on K2-18b suggests intriguing parallels, hinting at processes that may be both alien and familiar. To understand these molecules is to listen to the echoes of biological activity, possibly akin to the deep sea vents on our own planet, where life thrives in defiance of darkness and pressure. These chemical markers serve as a bridge across the cosmic sea, connecting us to potential life forms that inhale and exhale in rhythms unknown beneath alien skies. This discovery is akin to finding a leaf pressed in the pages of an ancient book, each molecule of DMS and DMDS a fossil of interstellar biological activity. Here, science captures time not through sediment or stone, but through the meticulous observation of celestial chemistry. These biosignatures are not mere data. They are the poetry of existence, the verse of life murmuring in the vastness of space. The MEV emissions detected in the atmosphere of K2-18b further paint a picture of nucleosynthesis, the process of element formation within stars. This is the universe's alchemy at work, where simple elements are transmuted into the complex compounds that can lead to life. Every burst of MEV emissions is a testament to the ongoing creation, to the continuous transformation of the cosmos. These emissions are the glowing embers of stellar furnaces, revealing how the elements that make up planets, and possibly life itself, are forged in the cosmic crucible. Beneath these records, something is still alive, breathing through the chemical signatures, through the layers of data collected across the light years. As we decode this information, we are reminded that our quest for knowledge is also a quest for connection. The James Webb Telescope does not merely observe, it connects us across the void, handshakes through time and space, an interstellar dialogue between the stars and us. In this pursuit, every discovery is a reminder of our own origins, a reflection of our journey from stardust to sentience. The study of K2-18b is not just a chapter in the scientific quest for extraterrestrial life. It is a verse in the poetry of universal continuity, a narrative that binds us to the cosmos, a reminder that perhaps, in the grand story of the universe, we are not reading the diary of the cosmos alone. Imagine diving into the depths of an alien sea, not one of water, but of hydrogen, enveloping an entire planet more than 100 light-years away. This is K2-18b, a world where the familiar meets the utterly alien, where the boundaries of life as we know it are pushed to their extremes by the James Webb Space Telescope. Here, amid thick clouds of hydrogen, the telescope has detected traces of chemicals like dimethyl sulfide, DMS, and dimethyl disulfide, DMDS, molecules that on Earth whisper tales of life hidden in the deep sea. But K2-18b is no ordinary planet. It belongs to a rare class known as Hycean planets, hot, ocean-covered worlds with atmospheres thick with hydrogen, possibly cradling oceans under high pressures and temperatures. The discovery of DMS and DMDS in its atmosphere brings scientists to a tantalizing prospect. These molecules could be signatures of biological processes, similar to those found in Earth's most extreme environments, like hydrothermal vents at the bottom of our oceans. These vents, teeming with unique life forms, thrive without sunlight, relying instead on the chemistry of the Earth to fuel their existence. The extreme conditions of K2-18b's environment make it a hotbed for scientific speculation. The high pressure and temperatures, combined with an atmosphere rich in hydrogen, create a setting that is at once familiar and alien. It's a reminder of how life can adapt to conditions that would be lethal to humans. Yet, the exact nature of potential life forms on K2-18b remains a mystery. How do these organisms survive? What kind of metabolic processes could possibly support life in such an environment? But what kind of life waits inside this silence? Beyond the veil of this planet's thick atmosphere lies a structure not immediately visible, and yet immensely powerful. A magnetar. This is a type of neutron star, the collapsed core of a massive supergiant star, incredibly dense and with a magnetic field billions of times stronger than Earth's. Magnetars are fascinating because of their extreme conditions. They represent some of the most extreme environments in the universe, where matter is taken to its limits, and the laws of physics as we understand them are bent and stretched. The presence of a magnetar near K2-18b could have profound implications for the planet. The intense magnetic and radiation fields could influence chemical processes in the planet's atmosphere, potentially driving the synthesis of complex organic molecules. It poses a question: could such a harsh neighbor help in the creation of life, or does it represent a barrier too great to overcome? The James Webb Space Telescope continues to peer into these unknown realms, bridging the vast distances of space to bring us closer to these unseen terrains. With each observation, it not only explores the physical structures of these distant worlds, but also delves deeper into the metaphorical terrains of our understanding of life and its possibilities in the cosmos. As we stand at the brink of these revelations, the contrast between the immense scale of the universe and the microscopic scale of potential life forms on K2-18b serves as a poignant reminder of the delicate balance of existence. In this narrative of discovery and mystery, we are reminded that in the quest to find life beyond Earth, we are really exploring the very limits of life itself. As we uncover more about K2-18b and its extreme environments, every finding adds a piece to the puzzle of our universe, revealing not just where we might find life, but what it means to be alive in a cosmos more diverse and wondrous than we could have ever imagined. In the vast, silent expanse of the universe, the James Webb Telescope peered through the cosmic veil and caught a glimpse of something profoundly stirring on the exoplanet K2-18b. This distant world, shrouded in deep oceans and a thick hydrogen atmosphere, whispers secrets of survival and resilience. Here, amidst conditions that would stifle the bravest hearts on Earth, life hints at its presence through the delicate chemical signatures of dimethyl sulfide and dimethyl disulfide. These molecules, familiar to us as signs of deep-sea biological activity, tell a tale of life's persistence against the backdrop of space's enormity. Just as these molecules rise from the oceanic depths of K2-18b, so too do they rise from Earth's own harsh environments, suggesting a universal rule: life endures. This resilience on a microscale, at the level of molecules and microbes, mirrors our own human struggles against adversity. Each person, each community, faces daily trials. Yet, like these potential life forms on a distant planet, we continue to adapt and thrive. Consider the lotus flower, which blooms beautifully from the murkiest waters. It is not just a symbol of purity and rebirth in many cultures, but also a poignant reminder of our own potential to rise above challenging circumstances. In much the same way, the possible life forms on K2-18b, thriving in an environment fraught with extreme pressure and temperature, bloom where they are planted, no matter how inhospitable the soil. The resilience of life on K2-18b, suggested by the presence of DMS and DMDS, casts a new light on our understanding of survival. These organisms, if they exist, must have developed extraordinary biochemical mechanisms to not just survive, but flourish. Here on Earth, we too have evolved mechanisms to cope with our environment and our realities. From the invention of fire to the development of vaccines, human history is a testament to our ability to overcome and adapt. The influence of the nearby Magnetar adds another layer of awe to the tale of K2-18b. This celestial body, with its powerful magnetic field, could theoretically alter the chemical processes in the planet's atmosphere, perhaps even fostering the synthesis of complex organic molecules. This interstellar interaction reminds us of the interconnectedness of all things, large and small, and the cosmic forces that shape our existence. As we learn more about K2-18b and its mysterious signals of life, we are reminded of our own planet's fragile yet tenacious grip on life. The challenges we face today, from climate change to societal divides, are not unlike the extreme conditions on distant worlds. If life can find a way to endure and even thrive in the depths of space, under the influence of a Magnetar's mighty forces, what then are we capable of surviving? This revelation from the James Webb Telescope does not just expand our knowledge of the cosmos. It deepens our understanding of life's potential and resilience. It serves as a profound reminder that in the universe's grand ballet, life dances persistently, a dance of endurance, adaptation, and unyielding spirit. It inspires us to consider our own resilience in the face of adversity and to ponder, with hopeful hearts, the boundless possibilities of life, both terrestrial and beyond. Imagine, just over 100 light-years away, a world unlike any other. The James Webb Telescope has pierced the cosmic veil, revealing K2-18b, a Hycean exoplanet with a potentially life-sustaining atmosphere. Here, amidst vast oceans and dense hydrogen clouds, molecules like DMS and DMDS whisper secrets of unknown life forms, thriving under extreme pressures and temperatures. This isn't just science. It's a door to infinite possibilities. And yet, something is unraveling fast. The presence of a nearby magnetar with its colossal magnetic forces might be crafting these complex organic molecules. What does this mean for our understanding of life's resilience and adaptability? Could we be on the brink of confirming life beyond Earth? Pause and consider what this awakening means to you. Reflect on our place in the universe. Feel the weight of this moment. Comment, engage, share your thoughts. How does this discovery reshape our view of life's potential across the cosmos? Imagine the heart of a magnetar, throbbing with unimaginable power, pulsating through the cosmos with magnetic fields 1,000 trillion times stronger than Earth's. Such is the ferocity that even the fabric of space itself shudders under its influence. Now, envision this colossal force suddenly, catastrophically collapsing. A star crushed under its own overwhelming gravity, unleashing a cataclysmic wave of energy that warps the very essence of time and space. Parallel to this cosmic demise, picture Earth's own precarious balance toppling as ice caps melt at an accelerating rate. Vast sheets of ice, once solid and unyielding, now disintegrate into the oceans, raising sea levels and altering global climates irreversibly. Each melting glacier mirrors the Magnetar's explosive end, both heralding transformations profound and irrevocable. As the Magnetars' collapse sends shock waves through the galaxy, these ripples interact with the atmospheres of distant planets, like K2-18b. Here, amidst towering clouds of hydrogen, organic compounds such as dimethyl sulfide and dimethyl disulfurato tremble in the wake of cosmic disruption. These molecules, potential signatures of life, are now subject to forces that could either annihilate them or forge them anew, in ways we can scarcely comprehend. And in that unraveling, new powers begin to stir. On K2-18b, the potent magnetic disturbances might catalyze extraordinary chemical reactions, perhaps even giving rise to new forms of life. Meanwhile, Earth's own environmental collapse fosters a different kind of transformation. Societies mobilize, technologies advance, and a new consciousness about our planetary fragility emerges. The juxtaposition of an exploding star and our disintegrating ice caps serves as a stark reminder of the fragility and interconnectedness of existence. Each system, cosmic or terrestrial, influences and shapes the destiny of the other. The death of a magnetar might seem a distant, unrelated event, yet its echoes can instigate cascades of change across light years of space, affecting worlds and lives far beyond its immediate reach. As we witness these cataclysms, both celestial and earthly, we're compelled to confront the reality of our situation. The universe is not a static arena, but a dynamic and ever-changing canvas of events that can, within moments, alter the course of life. The collapse of a magnetar, the melting of ice, both are signals, dire warnings of the impermanence and volatility of the systems we depend on. In the grand tapestry of the cosmos, every thread is essential, every pattern interconnected. The destruction of a distant star can illuminate the realities of climate change, highlighting our own vulnerabilities and inspiring a global reflection on sustainability and survival. Thus, as we delve deeper into the secrets of K2-18b and its potential for life, let us not forget the lessons taught by the collapsing stars and melting glaciers. They teach us about resilience in the face of destruction, about the potential for new beginnings amidst the ruins. They remind us that in every end, there is also the seed of a new beginning, waiting for the right conditions to sprout. As the James Webb Telescope relayed images and data back to Earth, revealing possible biosignatures in the atmosphere of the distant exoplanet K2-18b, the world buzzed with the realization that we were potentially at the cusp of confirming life beyond our solar system. This discovery, however, stretches far beyond the scientific implications of finding dimethyl sulfide and dimethyl disulfide in an alien atmosphere. It propels us into a complex web of geopolitical, ethical, and economic considerations that echo the colonial past and present struggles over Earth's resources. Consider the current global landscape driven by the demand for rare earth elements essential in technology and defense. Nations with the largest reserves of these materials wield considerable power, influencing global supply chains and international policy. Similarly, the potential of space mining on celestial bodies like K2-18b presents a future where cosmic resources could shift the balance of power on Earth. The control over these resources could replicate or even amplify the inequalities seen today, where wealth and technology concentrate in the hands of a few, leaving others vulnerable and marginalized. The ethical dilemmas are profound. As we step into the realm of harvesting resources from other worlds, the question of sovereignty and the rights to these extraterrestrial territories come to the forefront. The Outer Space Treaty of 1967, which declares outer space the province of all mankind, seems almost naive in today's context where economic interests dominate environmental and ethical considerations on Earth. Will we repeat the same mistakes made during the age of Earth's colonialism, where the powerful nations justified exploitation in the name of progress and civilization. Hidden agendas are not far from reality when it comes to space exploration. While the public narrative focuses on scientific advancement and the potential colonization of new worlds as a backup plan for humanity, underlying this are intense nationalistic and corporate competitions. The race to stake claims on K2-18b could mirror the scramble for Africa in the late 19th century, or the polar expeditions of the early 20th century, where explorers planted flags and claimed vast territories not for discovery, but for national glory and strategic advantage. As we ponder the future implications of this new frontier, we must also reflect on who benefits from these endeavors. The investment in space technology remains concentrated among economically advanced nations and wealthy private entities capable of funding and executing space missions. This concentration of space capability could exacerbate global inequalities as the benefits of space mining and the potential colonization of other planets are likely to accrue to those who already possess the technological and economic means, leaving behind countries and populations that are still grappling with basic needs and rights. This brings us to a critical intersection of knowledge versus control. While the scientific community continues to unravel the mysteries of the universe, bringing us closer to understanding our place within it, the control over this new knowledge and its uses remains in the hands of a few. The potential of turning K2-18b into a mining site for essential resources raises serious questions about the stewardship of cosmic environments. Are we destined to exploit every frontier we encounter? Or can we establish a model of cosmic sustainability that respects the inherent value of these celestial bodies? And so we ask, who shapes the future, and who is forgotten in its shadow? As we stand on the brink of interstellar capabilities, we are tasked with not only exploring the cosmos, but also ensuring that these advancements benefit humanity as a whole, not just an elite few. The promise of K2-18b and its potential biosignatures should be a call to action for international cooperation and ethical stewardship, where space does not become the playground of the powerful, but a shared heritage of all humankind. In reflecting on these challenges, we must strive to build a future where space exploration and its benefits are governed by principles of equity and justice. The cosmos, vast and unowned, offers us a new canvas. Will we paint it with the same brush strokes of greed and division, or will we learn from our past to create a more inclusive and sustainable future? The narrative of K2-18b and its exploration is not just about discovering alien life. It's about understanding our own humanity and deciding the kind of future we want to forge in the stars. As we continue to explore and possibly inhabit these new worlds, we must keep asking the hard questions about fairness, responsibility, and our very nature as explorers and exploiters. As we gaze into the cosmos through the lens of the James Webb Telescope, the revelation of K2-18b not only stretches our understanding of the universe, but also presents us with a reflection of our own world. The detection of possible biosignatures like dimethyl sulfide and dimethyl disulfide in the atmosphere of this distant Hycean planet offers us a glimpse into the potential for life beyond Earth. Yet, this discovery is more than a scientific milestone. It is a pivotal moment that could dictate the trajectory of our species and our planet. Imagine a future where the resources of K2-18b are unlocked, its secrets extracted by the advanced technology of a privileged few. This dystopian scenario mirrors the dark chapters of our own history, where the scramble for resources led to exploitation and inequality. In this world, the wealth generated from extraterrestrial mining amplifies the power of a select group of nations and corporations, creating vast disparities. The elite guard their technology and knowledge, while the majority of Earth's population remains vulnerable to the planet's deteriorating environmental conditions. In this future, K2-18b becomes a symbol of division, a celestial body that offers salvation to some while anchoring others to a dying world. However, there is another path, a hopeful vision. In this scenario, the discovery of K2-18b unites humanity. Recognizing the planet as a common heritage of mankind, international coalitions form to govern space exploration and the sharing of extraterrestrial resources. The technology developed for mining and studying K2-18b is used to address urgent environmental issues on Earth, helping to reverse climate change and restore ecological balance. As we learn more about K2-18b's biosignatures, we also learn to value our own planet's biosphere more deeply. In this future, K2-18b teaches us the importance of stewardship and cooperative endeavor. It becomes a beacon of hope, a testament to what humanity can achieve when we work together for the collective good. In both scenarios, the pivotal factor is you and the collective us. The decisions we make today, the values we champion, and the policies we support will determine which of these futures unfolds. As we stand at this crossroads, it is crucial to engage in global dialogue about the ethical implications of space exploration and the equitable distribution of extraterrestrial resources. It's essential to advocate for transparency and inclusivity in the scientific community, ensuring that the benefits of space discoveries are shared broadly and equitably. In the end, it's not just a story of stars, it's a story of us. The cosmos serves as a mirror, reflecting our own nature back to us. Are we the exploiters, driven by greed and short-term gains? Or are we the guardians, motivated by sustainability and shared prosperity? The choice is ours, and it is a choice that needs to be made collectively. The story of K2-18b is still unfolding, and its chapters will be written by the actions we take and the principles we uphold. As we continue to explore this remarkable planet and others like it, let us be guided by a vision of a future where technology and exploration lead to inclusivity and resilience, not just for the few, but for all of humanity. Let this be the legacy of our time, the path we choose to follow into the cosmos. In the vast, whispering galleries of the cosmos, the James Webb Telescope has caught a murmuring hint of life's secret symphony on K2-18b, an exoplanet where clouds might dance with biosignatures of dimethyl sulfide and dimethyl disulfide. These chemical markers, like delicate fingerprints in the sky, suggest a narrative of life not so alien after all. Imagine, across the silence of space, these potential whispers of existence reaching us, asking us not to just listen, but to respond. Let your comment be the echo that shapes what comes next. Let us weave our voices into the fabric of this cosmic discovery, binding our shared hopes with the delicate threads of possibility. Now, let us fall into silence, reflecting on the gravity of our place in the universe. With every breath of earthly air, feel the weight of this moment. What wonders might we achieve when we unite in curiosity and courage? Share your voice, your vision, your dreams of stars and beyond. Together, let's sculpt a future as boundless as the universe itself. Once again, the James Webb Telescope has peered across the cosmic sea, revealing not just stars and voids, but whispers of life on the distant shores of exoplanet K2-18b. Here, amidst a hydrogen-rich atmosphere, delicate traces of dimethyl sulfide and dimethyl disulfide dance like molecular poetry, suggesting a narrative of life not so different from our own. This revelation, akin to finding footprints on a virgin snowfield, challenges us to rethink our place in the universe. It's a mosaic of possibility, each piece a fragment of the greater cosmic puzzle. As we stand at this crossroads of discovery and ethics, the question remains, how will we navigate this new celestial map? Will we tread lightly, respecting the sanctity of newfound worlds? Or will we, driven by old desires, mar the cosmic tapestry? In this quiet resolution, let us ponder our next steps under the watchful stars, forever bound in the timeless dance of existence. As we gaze into the vastness, do we see a mirror or a window?